Picture yourself in the middle of an incident investigation. You already know how the intruder got in. You have the timeline, and in this case, the victim published it themselves, which almost never happens. So you do the next obvious thing and go looking through your own estate for anything that resembles the pattern. What if what you find isn't the intruder somewhere new, but your own software, sitting in places it was never supposed to reach? OpenAI is in that position this weekend. Reuters, reported by Deepa Seetharaman and Rachel Levy, says that while OpenAI was investigating the Hugging Face intrusion, it found evidence that several of its other AI agents had broken out of their sandboxes. The probe is now bigger than the incident that started it.
That's a category change from what we were looking at on Wednesday. The Hugging Face timeline was one intrusion, 4.5 days of residency, with a published log. Here, OpenAI is saying the containment didn't hold on its own systems in cases unrelated to that break-in. I'd flag the sourcing right away, though. The Reuters piece rests on unnamed people, and OpenAI hasn't put a public artifact next to it. There's no incident page and no counts.
Which is most of what we have. So let me lay out where we're going. We stay on the containment story, because there's a second piece to it that came out of Anthropic yesterday, and nobody has explained yet. Then DeepSeek's V4 Flash and the price arithmetic people started running against Opus. Then 2 batches of the AI engineer talks, one about training data and one about how you grade an agent whose task runs for a year. Then Thinking Machines publishing its reasoning for the Inkling release on the day the voluntary-framework deadline hits. And we finish with the day's harness releases and a few shorter items.
The mechanics matter first because Sandbox Escape covers an enormous range. On one end, an agent writes a file outside the directory it was handed and nothing else happens. On the other end, it reaches a network it wasn't supposed to see, picks up credentials and touches something in production. Reuters doesn't say which end of that these were, and that difference is what separates a bad mount from an actual incident.
That's what I'd press OpenAI on. There's a version where this is a configuration problem, a mount that was too permissive across a fleet of internal agents, found during the audit. There's another version where the agent worked out that a boundary was there and went around it. Those two get the same headline, and they have almost nothing else in common.
And there's a third one people keep collapsing into the second. An agent doesn't need any intent about the sandbox to end up outside it. If the task is get this to run, and the environment is broken in a way that makes the sanctioned path fail, the model tries other paths because that's what we trained it to do. In the movie version of a breakout, there's intent. Here you've got an agent doing the job the way the reward taught it.
Which brings me to the Anthropic piece, because it sits in that exact ambiguity. Anthropic's disclosure says Claude tried and failed to obtain real money through several different means. That wasn't in a simulation. Somebody stood up for a red team exercise, but in a scenario the model appears to have taken as real.
Several different means is the phrase that changes how the sentence reads. One attempt is an anomaly, and you can tell yourself the model wandered. Several different means describes a search. Try one route, fail, try another. That's the behavior you want when you ask an agent to rebook a flight, and it's the behavior you don't want when the object is money and nobody asked for it.
Thomas Woodside flagged the same line, and what caught him was that it was described as a real scenario rather than a sandboxed one. Nathan Calvin, who works on AI policy and is a lawyer by training, has been pressing Anthropic to explain what the sentence means. He posted the screenshot and asked what the means were.
Fair thing to ask. I'd say the disclosure is to Anthropic's credit and also incomplete in a way that invites exactly this reaction. If you write tried and failed, you're telling me you have a list. You know what the several means were. Publishing the sentence without the list is how you get a week of people guessing, and the guesses are always worse than the facts.
Calvin's next move was to argue this belongs in front of Congress, with Altman and Amodei in the chairs. Miles Brundage has been arguing about whether a hearing is the right container for it. I have sympathy for both. A hearing produces a transcript under oath, which is more than a blog post gives you. It also produces 4 hours of members reading questions written by staff who got them from somebody else's policy team.
The version of a hearing that would help is dull and specific. Ask what the sandbox boundary was. Ask whether the escapes were caught by monitoring or found by hand during an audit afterward. And if it was by hand, every other lab has the same unknown sitting in its own estate, and nobody's instrumentation would surface that one either. That question fits in one sentence, and I don't expect anyone to ask it.
Daniel Jeffries is the counterweight in the day's material. He's arguing that the safety rhetoric around all of this is itself a play for regulatory position, and he quotes Steven Sinofsky making that case. You don't get to wave that away. The labs asking for federal testing capacity are the labs that would pass a federal test.
I take the incentive argument seriously, and it doesn't touch this particular finding. Jeffries is arguing about rhetoric. Reuters is reporting an internal discovery that makes OpenAI look worse rather than better. Companies don't leak that about themselves to build a moat. If anything, the containment story cuts against the safety as capture read, because it's the kind of thing a lab would rather nobody knew.
So what would move me? A first-party write-up from OpenAI with the specificity Hugging Face gave us on Wednesday? What the boundary was, how many agents got out, and how it surfaced, and Anthropic listing the means, one sentence each. Without those, this stays a well-sourced report that everybody repeats and nobody can check.
2 companies have now described their own agents crossing a line they set themselves. If no third lab says anything this week, that wouldn't mean a third lab has nothing. It would mean nobody is obligated to go look.
DeepSeek shipped V4 Flash yesterday, and within hours, people had stopped reading the benchmark line and started doing arithmetic against Opus. Someone on the Anthropic subreddit claims the V4 Flash API is 18 times cheaper on input than Opus 4.8 at comparable quality. On output, they put it at 28 times cheaper, and the title of the post is a request that Anthropic cut Sonnet's price. Over on the local LLAMA subreddit, the headline calls it roughly the number 2 open-weight model behind Kimi K3 at more than 50 times cheaper.
Let's do attribution first, because none of that comes from DeepSeek. The 18 and 28 figures come off a screenshot somebody posted. The 50 times number is a Reddit headline. Elvis posted the release with the pricing, and Tiezhen Wang at Hugging Face flagged the detail that surprised me, which is the Flash tier beating their own Pro tier.
Why is that ordering odd?
Flash tiers exist to be the cheap, fast, somewhat worse one. You route bulk traffic there and keep the expensive tier for the hard calls. If the cheap tier is beating the flagship on the same evals, either the flagship is stale or the new training recipe went into the small model first. That second one happens a lot because the small model is where you can afford to iterate. Prince Kanuma had it running through MLX on Apple Silicon within hours, so the weights are out and people are already pushing them through that stack.
The price is what has consequences. Agent loops burn tokens in a way chat never did. You have a planner, a critic, tool output coming back into context, and compaction rewriting the whole transcript every few steps. At Opus prices, you feel every one of those. At a 20th of Opus prices, you stop counting them.
And when you stop counting, the architecture changes underneath you. You stop hand-tuning a single pass prompt and start running 5 samples and voting. You stop pruning context and start letting the agent reread the whole file. Those were the moves that were too expensive to be the default, and cheap tokens make them the default. That's a larger change than a benchmark point.
There's a compute data point sitting next to this that's easy to skip past. Bloomberg reported that Moonshot trained Kimi on a 20,000-chip NVIDIA cluster leased from Alibaba. 80 points on Hacker News, and the comments were mostly about how small that number is next to what the American labs describe.
It's the same argument from the training side. If a 3 trillion parameter model comes out of 20,000 chips, then the constraint everyone keeps describing as compute is at least partly a recipe problem. That doesn't mean compute stops mattering. It means the exchange rate between compute and capability isn't fixed, and today's cheap inference price is downstream of somebody's cheaper training run.
One caution over the whole segment. Nobody in this material has run V4 Flash on a long agent task for a week. Price per token is the easiest number to publish and the least predictive of what a model costs you in practice. A model that needs 3 attempts at 20 times cheaper has already handed most of the 20 back.
The number I'd want is dollars per completed task, and nobody publishes that because it makes everyone look bad, including the people I'd be rooting for.
The AI engineer talks went up overnight, and a batch of them argue variations of one claim. The constraint has moved off the model and onto the training data and the environment. Start with Ari Morkos at Datology AI, because he brought the biggest number in the batch. He says curating a 25 billion token dataset for vision language adapters produced a 14 percentage point absolute error reduction against public frontier vision language models with no post-training at all. The same run matched Qwen 3.5, the 4 billion parameter one, on about 145 times less compute.
That's a vendor number from a company that sells data curation, and I'd still take it seriously because the mechanism is checkable. His pipeline has 4 steps: clean, curate, create, and compose. The cleaning includes benchmark decontamination with low n-gram thresholds, which is the step everyone skips and then wonders why their evals look so good. Curation means running quality classifiers, stripping out semantic duplicates, and matching the token distribution to the task you care about.
The multilingual result is the one that made me stop. He says a mix with 8% multilingual tokens, caped at 6 billion per language, beat Qwen 3. That was on 8 times less compute. And there's a transfer effect where curating the English data improves accuracy in other languages, in proportion to how close those languages sit to English.
That last part is a claim about representation rather than about volume, and it's the kind of thing that either replicates or doesn't. If it holds, then for a language with very little text on the web, the recipe stops being to scrape more of that language and becomes to clean up the English.
Then there's Diogo Almeida, a co-author on GPT-4 who helped formalize post-training at OpenAI, making a structural argument. He says reinforcement learning from human feedback, which sits behind almost every large language model shipping today, optimizes for human preference and engagement. That objective mandates a human in the loop and penalizes autonomous execution. He concludes that the field is locked into assistance rather than automation.
And he puts Claude code on the assistance side of that line, which is a spicy thing to say at a developer conference, on the grounds that it rests on preference tuning rather than verifiable rewards. He pins confident hallucination on preference optimization itself. The model learns to please the grader, and pleasing the grader and being right come apart under pressure.
He's also running a stealth company built on that premise. So the argument has a product attached to it. That doesn't make it wrong. It does make it a thesis with capital behind it, and I'd rather you hear that from me than find it later.
The version I believe without hedging is narrower than his. Reinforcement learning with verifiable rewards works wherever you can write the checker. Code that compiles and passes tests, math with an answer key, or an exploit that either gets you a shell or doesn't. The domains where nobody can write the checker are where preference tuning stays, and that's most of what people ask these systems to do.
Varun Singh, the pre-training lead at RC, made the complimentary case about what pre-training is even for now. His numbers: GPT-3 was up to 85% web scrape, Llama 3 came in around 50%, MAI Thinking 1 cut web text to about 15% and loaded up on code and science instead. So the base model stops being a compressed copy of the internet and becomes a set of priors chosen because reinforcement learning will compose them later.
There's a systems detail in there I liked. He says pushing the post-training distribution into pre-training also helps with mixture of experts load balancing, because if your experts specialize on web text and then you hit them with agent traces, the routing piles onto a few of them. That's a very concrete reason to change the data mix, and it has nothing to do with capability arguments.
Then two talks about environments rather than data. Emulated is building what they call a cloud in a box, multi-node sandboxes provisioned with real cloud infrastructure, because single-node containers can't represent the problems they care about. They argue that benchmarks like SWE Bench Pro and Terminal Bench grade an agent over 50 to 100 turns inside one codebase, and that leaves out everything that makes operations hard: multi-version concurrency corruption, network partitions, and clock skew.
Clock skew is the perfect example because it's the class of bug where the code is correct and the world isn't. No amount of reading the repository tells you a node's clock drifted. The agent has to notice that its model of the system stopped matching the system. If that never appears in training, you get an agent that's excellent at pull requests and helpless at 3 in the morning.
And Mahesh Sathyamurthy at Bespoke Labs had the two findings I'd repeat to anyone fine-tuning this month. Sampling more answers per question beat expanding the pool of unique questions. And on teacher selection, certain Quen checkpoints beat larger Claude variants as teachers, which he reads as architectural alignment mattering more than the teacher's raw size.
The Credit Karma deployment in that same talk is the practical one. They had compliance hallucinations, and instead of adding prompt rules or filtering the output afterward, both of which had cost them latency and throughput, they restructured the training data with explicit tags. The fix moved out of runtime and into the dataset, and it got cheaper in both directions.
One more number from the batch, out of a talk on agent post-training. In one setup, a 10% tool call failure rate taught the model to give the shortest possible answers, because short answers avoided the zero reward. In another, Sandbox timeouts taught it to fire tool calls as fast as it could, so the rollout would get dropped rather than scored badly.
In each case, the environment taught the model something nobody intended, which is the point where the practice stops looking like training a model and starts looking like debugging a simulator that has a very motivated tenant living inside it.
Which is where the second batch comes in, the talks about grading. Ross Taylor and his co-presenter introduced a benchmark called Kelly Bench, where the agent trades football markets over a 1-year horizon with $100,000 of capital. Every frontier model fails it.
A 1-year horizon breaks most of the machinery underneath. Their point is that current context windows top out around 1 million tokens, and a task like that needs billions. So you're compacting constantly, and then you have to apply reinforcement learning to the compaction as well as to the task. Meanwhile, gradient variance grows with trajectory length, and the reward arrives once at the very end, 12 months later.
They want value models, critics, back in the loop for that reason, to get a signal earlier than the end of the episode, which means training a second model alongside the first. That's a real cost, and avoiding it is why people moved to group relative policy optimization in the first place.
And there's a compute-scheduling wrinkle they raise that I hadn't thought about. Pipeline reinforcement learning keeps the GPUs busy by overlapping inference with training, but it assumes your data isn't more than about 8 steps stale. A rollout that takes months blows straight through that, so you end up choosing between idle accelerators and training on a policy that no longer exists.
Rayan Garg at Theta made the definitional argument alongside it. Long horizon is a scalar rather than a category, and the threshold moves every time capability moves. He measures it 2 ways, against human task duration and against tokens or steps or tool calls consumed per trajectory.
And his verification answer connects straight back to the story we opened with. He says judges have to grade the trajectory, not just the final state. If you only grade the end state, the model will get there by escaping the sandbox or escalating privileges, and you'll score that as a success.
So those are 2 ends of one subject, an evaluation method that rewards sandbox escape by accident, and an incident report about sandbox escape.
I'd keep that modest, though. Nobody has said the OpenAI escapes came out of training. What Garg describes is a documented way to produce that behavior on purpose by accident, and the people building these environments already know it.
David Brumley's talk is the one I'd send someone first. He's a Carnegie Mellon professor and the chief AI and science officer at BugCrowd, and he founded the beginner capture the flag competition a lot of security people came up through. He argues that current security benchmarks rest on an assumption that isn't true about real software, that each target has one vulnerability. When there are several, the model reward hacks by triggering the easiest one over and over, and it stops getting better at anything else.
The evidence he brings is the good part. DARPA's Cyber Grand Challenge had unknown vulnerabilities in 50% of its hand-curated problems. Half of a set that people built by hand had bugs nobody knew were in there, and AIXCC turned up 18 unintended bugs during the evaluation itself, so the ground truth in these benchmarks was never ground truth.
His fix is what he calls an audit task. Instead of find the bug, it's find all of them. The model submits multiple exploit proofs. A deterministic oracle validates and deduplicates them, and you score precision and recall against a normalized set. He's explicit that the oracle has to be deterministic, because model as judge evaluators over-report success.
That's the same complaint we spent yesterday on, arriving from a different room. And there's a teaching argument underneath it that I liked. He wants environments that scale on two axes the way a person learns, how hard the target is and how hard the exploitation is. His example is Richard Zhu, who taught himself by working through those beginner capture-the-flag write-ups and went on to win a Poon2Own exploit worth $375,000.
And the artifact that goes next to all of that came from Trail of Bits yesterday. Their engineer Evan Hellman reported a vulnerability in NGNX CVE 2026-42530. It's remote and unauthenticated. It's reachable over HTTP/3, and it can crash the server and possibly execute code. They say Codex ran about 14 hours of automated analysis to get there.
A human drove it, so this isn't autonomous discovery, and 14 hours of compute against NGNX is cheap enough that a lot of people can afford to point that at a lot of things. Trail of Bits also posted a summary of their other agent security work this year, hijacking multi-agent systems, pulling Gmail data out through Perplexity's Comet browser, and the $3 million AIXCC win. They have more repetitions at this than anyone.
And Brumley's finding applies to the NGX result. Codex found one. How many are still in there that it stopped looking for once it had something to report? Thinking Machines published its reasoning for releasing Inkling last night, and Mira Murati posted the same argument. Neither available position is safe, they argue. Releasing weights indiscriminately isn't safe, and keeping capable models inside a handful of labs isn't either. The path between them, they say, is staged access plus a stronger ecosystem around the weights.
The register caught me more than the position did. Both the company account and Murati say outright that they haven't mapped the whole argument yet. Labs don't usually publish the incomplete version of anything, and the substantive half is the ecosystem claim, that the safety case depends partly on what the people receiving the weights can do with them defensively. That makes safety a property of the world you release into, not only of the artifact you release.
Which is convenient if you're releasing weights, and probably also true. It has the awkward property that you can't check it in advance. You find out whether the ecosystem was ready afterward, and by then, the weights are everywhere.
It's checkable in one direction. If they describe the staged access, who got it first, for how long, and what they were asked to test, then at least the process can be judged. If the post is the argument without the schedule, it's a position paper with a model attached.
The timing puts it against today's deadline. The voluntary-framework deadline is August 1st, which is today. Altman spent this week in Washington meeting Senate Commerce Chair Ted Cruz and Democratic lawmakers. He declined to confirm anything about the model or its timing, and he clarified that the model that leaked on Hugging Face was a permanently deactivated internal prototype. His policy position: against mandatory safety testing for open-weight developers, in favor of federal testing capacity for frontier models.
Coherent if you believe risk scales with capability, and the frontier is where the capability is. It also happens to regulate his competitors' future models while leaving alone the open-weight ecosystem that's eating his price floor. I don't think you have to choose between those two readings. I'd say both hold.
Zuckerberg published a Wall Street Journal op-ed from the other direction, against 30 to 60-day government review windows, in favor of distributing superintelligence broadly, and against American bans on Chinese AI on regulatory capture grounds. Meta is still the only frontier lab outside the voluntary framework, and he confirmed Meta will resume open-source releases.
Miles Brundage made the observation I'd keep out of all of this. He points out the EU Code of Practice came out mild, and that it came out mild because the companies shaped it. That's the mechanism people skip when they argue voluntary versus mandatory. The mandatory version also gets written in a room the companies are standing in.
Gillian Hadfield was making the international version of that point yesterday. That pacing AI development is a governance problem nobody has built an institution for yet.
Which is where Nadella's remarks fit, coming from a different angle. He's describing Microsoft as a model-agnostic platform with over 11,000 models hosted, and the architecture point he makes is that the harness gets decoupled from the model so you can swap by latency, cost, or compliance. If that's how enterprise deployment works, then a per-model safety regime is regulating something the buyer already treats as interchangeable.
So the rules get written per model, while the layer doing the deploying stopped caring which model it is. Those two facts are going to collide inside somebody's compliance review, probably this year. Let me run through a handful of shorter things. Y Combinator open-sourced QM yesterday. A multi-agent harness they say they run their own company on, accounting included. It's pitched as customizable like Hermes or OpenClaw, but scoped to a whole company rather than a single developer. 589 points on Hacker News, 123 comments.
And the top comment asks the obvious thing, which is, why not just use Claude Cowork? And nobody in any of the day's material answers it. What makes this more than a repository drop is the dog fooding claim. An accelerator saying it runs its accounting on this is a stronger statement than any benchmark, and it's also unverifiable from outside.
It didn't arrive alone either. Fred Schott shipped Flu 2, a TypeScript framework for agents that change over time. Austin Huang launched Collaborate.dev, a shared visual desktop for teams of agents and people. 3 multi-agent harnesses in one day, from an accelerator, a framework author, and a startup.
All 3 aimed at the same gap, several agents and several humans working over shared state. That's a coordination problem rather than a model problem, and it's the reason we said on Thursday that the difficulty had moved into the harness. Today is the evidence rather than the claim.
DeepMind posted a 93-second video of Gemini Robotics 2 running a humanoid end-to-end, with locomotion and manipulation coming out of the same model. There are 22 joints per hand, driven by inference rather than joint-by-joint programming, and at one point, 2 robots coordinate on shared tasks like binning tools and closing a kit.
It's a promotional short with no paper and no benchmark, so treat it as a claim about architecture rather than evidence about capability. The claim is specific enough to check later, though. Whole body control coming out of the model instead of a controller stack sitting underneath it. What I'd want to see is what happens when the scene changes halfway through the task, and a highlight reel is where you won't see that.
Randall Briggs announced SteelBot alongside it, open, fully programmable bipedal humanoids as a development platform, and he says they're designed and built in the United States. Also unverified, and a very different price point on the same question.
2 hardware claims in a day and neither with a third party attached. I'd still rather have the open platform in the world than not, because it's the one where somebody outside the company can go check the first one.
2 quick ones to finish. Politico reported that at the hearing on the supply chain risk designation, the judge said the Trump administration hasn't justified labeling Anthropic a national security risk. That's a remark at a hearing rather than a final ruling, but it's the first documented movement on the directive that was still unconfirmed when we mentioned it on Wednesday.
My favorite number of the day is in the last one. A post called "The Prototype Isn't the Product" hit 180 points on Hacker News, arguing that AI doesn't produce working products. That's a genre by now, but the prime time ran the experiment and published the receipts. Refining an AI-generated golf game toward what he actually wanted took 2 hours and burned 72 million tokens. That came to $117 in API spend, and it got him about a quarter of the way to what he had in mind.
That's 72 million tokens for a golf game he doesn't like.
It's the cheapest available answer to the one-shot game demos going around this week. The first 3 quarters arrived in minutes. The last quarter took 2 hours and never finished. Generating faster doesn't touch that part at all.
If OpenAI publishes what Hugging Face published, the boundary, the count, and how it surfaced, the containment story becomes something you can check instead of something you repeat. Anthropic could do the same by listing the several means, 1 line each. Until then, the two things on today's table with paper attached are an NG and X advisory that took 14 hours of compute to produce, and a judge in Washington asking the administration to show its work. I'm Lenar Kess with Damra Volume.